Hey, I'm Code Hero, staff iOS engineer. I build production apps, and I explain what actually matters. No hype, no noise, just engineering. Everyone says Swift on Android is not real, that you need JNI, that it's experimental. I built a real Android SO file using Swift 6.3. No JNI, no hacks. If your mental model is still JNI, you're outdated. The problem was never Swift. It was the bridge. And Swift 6.3 changes how that bridge works. In this video, I'm not building an app. I'm building the core artifact Android needs, a native SO library. This is the foundation of everything else. Previously, I built a simple TapCounter app in Swift. But the goal wasn't the app. It was the architecture behind it. We're taking the TapCounter logic, extracting it into a Swift package, and compiling it into a SO so Android can use it. In this video, I'll show you the exact steps, using a real example. In the next one, we'll run the same Swift code on both iOS and Android. Let's start with what you need to generate the SO. Step 1, the toolchain. This is non-negotiable. You need Swift 6.3. If this step is wrong, nothing else works. Not Swift 5, not a random nightly build. The official Swift 6.3 release. The easiest way to install it is with Swiftly. Run the install command and let it set up the toolchain for you. Then verify it. You should see Apple Swift version 6.3, Swift 6.3 release. Step 2. Install the official Android SDK for Swift. This is not optional. This is what enables Swift to compile for Android. Use the install command from the Swift website. Run it, and let it set up the Android toolchain. Then verify it. You should see successfully installed as Swift 6.3 release Android artifact bundle. Step 3. The Android NDK. This is where most setups break. Swift relies on the NDK to produce Android binaries. No NDK, no SO. Install NDK 27 or newer. Set Android NDK home. Run the setup script. When it's done, Swift is officially connected to Android. Step 4. Create the Swift package. This is your foundation. Your Swift code should not live inside Android. It should live in its own module. Create a new package with Swift Package Manager. Then move your TapCounter implementation into sources. Make sure everything you need is marked as public. This is what the plugin will expose to Android. Step 5. Configure your Swift package for interop. This is one of the most important steps in the entire pipeline. Without this, you just have Swift code. With this, you have Swift code that Android can actually reach. Start by adding the Swift Java dependency. Then set your library type to dynamic. Android needs a shared library. That's how we get to a SO. Next, add Swift Java to your target dependencies. The generated code depends on it, so this step is not optional. And finally, attach the JExtractSwiftPlugin to the target. This is the key piece. It reads your Swift API and generates the Java wrapper and JNI bridge for you. No manual JNI, no glue code. Just Swift, compiled into something Android can call. Step 6. The config file. This is where most setups break. The plugin needs one more thing, a configuration file. Create a file called swiftjava.config inside your target's sources folder. The name and location must be exact. If it's missing, the build will fail. Inside that file, define two things. First, the Java package name. This is where the generated wrapper will live. Second, the mode. Set it to JNI. This tells the system to generate Android-compatible bindings. At this point, the plugin has everything it needs. Your Swift code, your package configuration, and now the generation rules. Step 7. Build the package. First, do a normal Swift build. This is your sanity check. If this fails, do not move forward. A successful local build tells you the package is valid, the plugin is running, and the generated bridge code compiles. But this is the important part. That first build is still not Android. It will give you a macOS dynamic library, a dylib. Good sign. Not the final result. The real target is Android. So now build again, using the Android Swift SDK target triple. For a physical device, use the ARM64 Android target. For the emulator, build the x86-64 target 2. This is the moment that matters. If everything is configured correctly, you'll get libTapCounter.so. That file is the proof. Swift has been compiled into a native Android shared library. What this actually proves: we didn't build a demo. We built a real Android native library using Swift. No manual JNI, no glue code. Just Swift, compiled into a SO. That means your business logic can now live in Swift and run on Android. Same language, same module, different platforms. And this is where things get interesting. This is not about replacing Kotlin. And it's not about forcing Swift everywhere. It's about control, where your core logic lives, and how many times you have to rewrite it. Swift just became a viable option for that layer. In part 2, we take this exact SO file and plug it into a real Android app. We'll call Swift directly from Kotlin, like it was a normal class, and we'll use the same logic on iOS without rewriting anything. If you want more breakdowns like this, subscribe. It's free, and it directly supports the channel. I'm Code Hero. See you in part 2.